The Earth's atmosphere contains several gases. Figure 1 shows the relative amounts of gases thought to be in the Earth's early atmosphere. Oxygen, small; carbon dioxide, large; nitrogen, small; water vapour, large. The amount of water vapour in today's atmosphere is much less than the amount in the early Earth's atmosphere. Explain why the amount of water vapour in the atmosphere has decreased. So in the early atmosphere we had a lot of water vapour, and that's because there were a lot of volcanic eruptions. So if you remember basically how it worked, we had a lot of volcanic eruptions basically bellowing out water and carbon dioxide, and then what happened was the Earth cooled, the water vapour condensed, and it rained to form the oceans. So that explains the first bit of our story. So 2 marks. You'd say the Earth cooled and the water vapour condensed to form the oceans. Now whenever you see this, you should think that this is an experiment that helps me understand what percentage of the Earth's atmosphere is oxygen. That's what this setup is about. You basically have 2 gas syringes with air in there, dry air, so there's not an abnormal amount of water in there, because you just want to have nitrogen, oxygen and argon, the normal atmosphere. You don't want water in there, so dry air. You have a metal that reacts with oxygen, and the idea is you heat the metal to make it more reactive, and as you plunge these back and forth, so you swish air over the hot metal, the oxygen will basically react with the copper. It will be removed from the atmosphere or the air inside these syringes, and the volume of air will decrease because there's now no more oxygen. The volume it decreases by indicates what percentage of oxygen was in the air in this tube, which represents the percentage of oxygen in the air in the actual atmosphere. So Figure 2 is used to find the percentage of oxygen in dry air. Syringe A contains 50 centimetre cubed of dry air, and syringe B contains no air. So 50 centimetre cubed here, and the plunger's fully inserted here, so there's no air here. The copper in the glass tube is heated strongly. The air in the apparatus is passed backwards and forwards over the copper until all the oxygen has been removed. The following results were obtained. The initial volume of air in the apparatus was 50 centimetre cubed. The final volume of gas in the apparatus was 40 centimetre cubed. So we basically reacted 10 centimetre cubed of the air, which must be the oxygen, with the copper here. Calculate the percentage of oxygen in this sample of dry air. So when you're working out a percentage change, what you are doing is you're finding out the real difference between 2 values, so 10 divided by the starting value, so we started with 50, and then times by 100. So remember, the real difference between the 2 divided by the original. That's how you work out percentage change. Again, very popular operation. Don't let these easy 2 marks escape you by not learning these mathematical techniques. So difference divided by initial value times 100. If you do that, you'll see it's 20%, and that's kind of handy because that's how we sort of estimate how much of our air is oxygen, which is 21%. At the end of the experiment, the apparatus and its contents are allowed to cool before the final volume of gas is measured. The apparatus and its contents must be allowed to cool because reading the volume while the apparatus is hot is dangerous. Not particularly, no. The glass tube may crack when it is hot and allow air into the apparatus, no. The gas has expanded when it's hot. So this is about getting an accurate measurement. The copper reacts with other gases in the air when it's hot. No, it only reacts with the oxygen, not with nitrogen, which is very stable, and not with argon, which is very stable. Oxygen is the reactive gas in that mixture of gases. So yeah, basically when a gas is hot, it takes up more volume and therefore will exert more pressure on the plungers outwards, so it will basically push the plungers out a bit, giving you an inaccurate reading. You need it to cool back to room temperature so the gases take up less space and you get an accurate reading, because right now the atmosphere isn't hot like the atmosphere in here, so we need to have it representative of the atmosphere outside to get a true reading. Finally, the Earth's earliest rocks contained iron sulfide, that's just iron and sulfur reacted together, and no iron oxide. Later the rocks contained iron oxide as well as iron sulfide. Explain what happened to allow this change to occur. So in other words, it's asking you to explain where did oxygen come from? So what happened and why did this change occur? So photosynthesizing plants evolved and produced oxygen. So that's the first thing you have to say. So plants evolved and carried out photosynthesis, which produced oxygen. iron reacts with oxygen. So that tells you what's happening, and then you explains why this iron reacted with oxygen to form oxides.